ahead. Hello, thanks for having us.
Okay. Also, thanks, Bob, for the invitation. So it's a great opportunity to present our latest and greatest camera technology to the people at SMPTE in Atlanta. So I was just presenting a similar part of technology at the SMPTE online conference last week. So there I focus especially on the imager, which we have developed for our latest camera, the LDX100. But today I want to focus a little bit more on the IP transmission and connectivity on cameras. So I have prepared a slide deck for that one. Maybe just a few words to myself. You can see my name is Klaus Weber. I'm based here in Germany, working for the camera factory, which is based in Breda in the Netherlands. Now working a little more than 25 years for the company. I'm the principal of camera solutions and technology, and as part of my role is to present the technology we have developed and which we are selling today to the market. So I have prepared, I need to check the following agenda. So first I give you a quick summary about the camera signal transmission history, the cables and connectors and the transmitted signals. Then I will talk about camera signal transmission over IP. First of all, why IP and what are the current solutions using IP? And then finally, I will talk about optimized camera integration into IP infrastructures. So the name for that one, as we call it, is native IP, the technology behind and the benefits. And then I will talk a little bit about additional features of the latest cameras towards IP infrastructures, and then give you a summary. And finally, at the end, we have time for questions, hopefully. So let's start with the first section, camera signal transmission history, cables and connectors and transmitted signals. So at the camera signal transmission, if we look back to the early days of television, the first live broadcast cameras, they had a lot of the processing done inside the camera control unit. So it means a lot of signals had to be sent between camera head and the camera control unit, or the CCU. And the interconnection between the two units was based on a multi-core cable. And every single signal which needs to be sent up and down between the head and the CCU had an own core. There was multiple coax cores and some power cores and some signal cores. So, and it's especially at the time when color television became used, the number of cores inside the cable almost exploded to a size or a number which was hard to be handled. It was around 1970 that Philips introduced the LDK5, which was the first camera using a complete new signal transmission, where all the signals between camera head and base station was sent over one single coax cable with a second shield, the so-called triax cable, and all the signal was multiplexed on different carriers. So this triax cable technology was a joint development actually between the CBS labs in the US and Philips Broadcast. And it was also awarded with a technical Emmy in 1991 already. So, but the requirements for HD with high speed or with UHD made it made it a requirement to change from triax to what is today's mainly used hybrid fiber cables. Fiber cables has a much larger bandwidth capabilities compared to triax or even multi-core, and the SMPTE ST311 cable and connectors became the de facto standard in the industry. So, but also the signals which was sent over the different kind of cables has changed. The multi-core solutions always had analog baseband signals. Every single signal had its own wire. The earlier triax solutions also used analog signals. And the analog signals was multiplexed on different carriers, but since the bandwidth requirements moved to larger bandwidths from SD to HD, from single speed to high speed, also the carriers needed to move up in the spectrum. So means they became a higher frequency, means you had more losses over the cable, and the maximum cable length at one point of time, especially in the times when HD became used, the maximum cable length was getting too short. So there was different versions of digital triac solutions. So earlier versions based on SD transmission, which used basically an SDI signal over triacs, was replaced later on by a second generation of digital triac solution, which used technologies not developed for cable use, but typically for wireless applications such as COFDM encoding and QAM modulation. And then in combination with a low latency wavelet compression, offered or gave us a solution to transmit HD signals from the camera head to the base station and return signals back to the camera head over long cable lengths or long enough cable lengths. So typically 1 mile, 1.5 mile of maximum cable lengths, which was sufficient for most of applications. But over the time, also requirements came up to support IP and now also to support UHD application, where triacs, as I mentioned earlier, became a bottleneck. So, and then first of all, the question asking why IP and what are the current solutions? So first of all, SDI has served the broadcast market well for many, many years. So, but what we can see today is that limitations become visible if we want to go beyond single speed UHD. So everything up to single speed UHD works pretty okay with SDI. So as you know, we have the 12 gig SDI standard since a while. But if you want to go UHD with triple speed, or maybe at a later point with 6 times speed or more, then even the 12 gig SDI connection does not give us enough bandwidth. So, and also since today's UHD standard or the 4K standard is not the end, many people talk already about 8K and then 8K with high frame rate. So SDI will not be able to support that one. On the other hand, what we also can see is that IP technology developments far outperform the developments in broadcast video for a long time already. And in addition, the cost of IP always goes down. And typically, the cost per gigabit or gigabyte or for any given bandwidth in IP typically is reduced to half every 14 months. Or in other words, every year, we only pay half for the same bandwidth. So in SDI, the cost stands still as best. So that's quite a difference. So over the time, IP became cheaper and cheaper for the same bandwidth, where SDI stay the same. So flexible requirements or flexible applications for UHD, high frame rate, high speed operation, and any combination of the different topics will be addressed much better with a format independent IP solution, rather than having an SDI standard which support 1.5 gig or the 3 gig or 12 gig. Have an IP connection which supports a certain bandwidth, and you can put anything in as long as it's not going above the given bandwidth. So actually, it's not a question whether IP will replace SDI in broadcast. It's more when it will happen. So, and as we have seen in the last, let's say, 1 or 2 years, IP is taking more and more share in the market and becomes the de facto standard for most of new applications. So what is available already today around IP? So first of all, we introduced 6-7 years ago already a concept called the cradle concept. So the camera base station consists of 2 different blocks. One is the mounting cradle and one is the electronic unit. And the electronic unit can be quickly slide into the mounting cradle and will be automatically connected to the cradle, which is already pre-wired. So the first version of this cradle was fully baseband only. So the small picture you see here on the right shows a number of these cradles pre-wired, but just with baseband signals. Around 2 years ago or 3 years ago, we introduced a second generation of this cradle, which in addition to all the baseband connections, which are still available, as you see them here in the right, it had an additional connectivity here in the middle, which is the IP bay. And in the IP bay, you can put up to 4 SFP plus modules. They can be 4 times 10 gig IP SFPs. It can also support 12 gig SDI, redundant interfaces. So this IP bay can be equipped depending on the requirements. So everything up to single speed UHD, even fully redundant and fully uncompressed, will be supported over the IP connectivity. But at the same time, all the connectivity is available. This is already fully IP.
Hey, Klaus, I lost your audio for about 30 seconds.
Oh,
it's back now. So I think
it's back now.
Yep.
It just lost it now on the last slide.
No, you can go to the next slide. Yeah, you said the 410s and all that, so that's where we left off. Thanks.
Okay, good. Just a summary. So it means the new or the current cradle supports baseband as well as IP side by side at the same time. So, and on the yellow cable here, which simulates the camera cable between the camera head and the base station, we also send IP signals already. So it was back in 2014. So for our first high-speed HD camera, the LDX86, we developed a new transmission solution. We call it the XF fiber transmission solution, where all the transmission, the signal transmission between head and base station was done over IP. So it's a 10 gig Ethernet connection. And since we have 2 fiber cables inside the SMPTE fiber cable, one fiber, the fiber A, can be used as the down link, and the fiber B can be used at the uplink. So it's a full IP-based transmission solution, and all the video streams inside that IP connection is using SMPTE 2022-6, which is the right format for this, because it's a point-to-point connection, and therefore 2110 would be the wrong solution here. But back in 2014, it was even not existing, so it was not an option. But again, even if it would have been an option, it would not be the right format, because 2022-6 is for point-to-point connection. So, but the nice thing is, since we use regular off-the-shelf Ethernet between camera head and base station, so the camera system can also use off-the-shelf hardware to connect camera head and XCU over a larger distance. So this is something what is called direct IP operation. At direct IP operation, there is a fully uncompromised connection between camera head and base station over IP networks. So it's not just simply sending a video signal up or down. So it's the complete signal protocol which we have between head and base station, but not running over a SMPTE fiber, but extended over an IP network. So this gives a lot of possibilities and a lot of benefits in many cases. So you can transmit a signal over more or less any distance without any latency other than the network latency. So in some tests, we connected 2 camera systems, which was based in London, to 2 camera base stations, which was based in Tokyo. And at the same time, 1 camera system in Tokyo was connected to a base station in London. So we had 3 cameras connected in 2 directions over 20,000 kilometers of fiber cable. So we could really do from one side of the globe to the other side of the globe a virtual uncompromised production. Even so, that was a test only and not a live production, but it could have been used for any kind of live application. And there are many use cases around the world using this technology already for a couple of years. And for example, the largest ever fully remote sport event was a ski championship, World Cup or World Championship for ski early last year in Sweden, where 50 full-size cameras where 13 of them was even running in high speed, was connected over 600-kilometer distance to the camera base stations, which was based in Stockholm in Sweden, where the cameras was based up in the north of Sweden in the mountains and doing all the shootings. So the full championship was done over direct IP. So this is a well-established technology already available since 2014. But the development continued, and people was asking, what can be the next steps of camera integration into full IP infrastructures? Because once you have a full IP broadcast infrastructure, typically baseband signals are not required anymore. And even if baseband signals are required in a smaller number, they can be generated by using IP gateway cards. And the power which is required to operate a camera can be inserted into the camera cable by a local power supply. So then the question is, why still use a camera base station on the receiving side or any other hardware to convert the signals coming from the camera back to the signals required in the production? Why don't you stay at IP? So why not use then off-the-shelf hardware to connect the camera to the IP infrastructure and have no dedicated camera hardware, whatever? And this is what we did now. So we reinvented the transmission a number of times. As said, in 1968, we introduced triacs, later on HD triacs. Then we introduced the cradle concept in 2013. And then in 2016, the direct IP. 2 years later, followed by a version where we had external compression added to the direct IP connection. Based on the NIMPRA solution from Net Insight. So, and now this year at the virtual NAB, we introduced a technology we called native IP. And with native IP, the camera chain is no longer an endpoint at your IP network, but it is an active node inside your network. So the camera by itself integrates all the functions which historically was done by the transmission and the base unit. And this altogether we call native IP. At native IP, there is no hardware other than the camera head by itself, with the exception of a power supply and a control unit. And the control unit, I mean a camera control panel. So native IP stands for a camera that doesn't rely on any base unit or any hardware to manage all the communication, but the camera itself manages all the communication. So it's really a high performance player in the network. But the camera also does, for example, things like IP gateways functionality. So the camera can convert any IP stream which arrives on the camera into baseband signals, or it can convert baseband signals into IP streams on the camera by itself. And the camera supports, of course, all the SMPTE, the current SMPTE standards, the 2110 standard, -10 for PTP. And PTP is really done straight from the camera. It's not a PTP signal which arrives on a camera base station and then converted inside the base station into a black burst or a tree-level sync signal going to the camera head. No, the PTP signal, the timestamp starts at the moment the signal leaves the imager. So it's as early as possible. It's using PTP already to synchronize all the signals. The good thing with that one is, if you have multiple cameras arriving over different ways with a different latency, So it doesn't matter because the timestamp has been set at the output of the imager. So on the receiving side, you know exactly when the signal from that camera or from that source was taken. And you can perfectly match the signals, even if they have a different latency because they come from different places. And of course, the camera supports SMPTE 10-20 and 30 for the video and audio essences and for the intercom. So it's fully supported standard. And we, of course, make sure that we support also other vendors' equipment, such as intercom equipment from all the different vendors, which are supporting 2110-30 streams. And of course, the camera fully support AMWA NMOS, ISO 4, ISO 5 for discovery, connection, and registration purposes, but it also supports ISO 7 for events management, and here in particular for camera all the tele control. And here again, we work with third-party suppliers to make sure that the tele commands will be fully compliant to the standard, and it works together with all the different vendors' equipment. Native IP support or must support a wide range of bandwidth because the camera can run in HD, for example, in single speed. It can run in 3G single speed. It can run in all the different HD formats in high speed. The camera supports UHD single speed. The camera supports even UHD today up with 3 times speed. So, and if we look for the bandwidth requirements, it's quite a large range. So in case of HD single speed, we need only 1.3 gig. That's the maximum we need for one single stream in HD, fully uncompressed. In 3G, it's double of that. It's around 2.7 gig. But of course, UHD single speed already requests 11 gig. So an 11 gig, for example, would not fit into a 10 gig connection. So we would need to go to a 25 gig SFP. On the other hand, as that the camera supports also UHD with triple speed. And triple speed means you need to provide 4 streams. 3 times the 3 different phases plus the combined output for the live feed. So it means we have 4 times UHD uncompressed, means 4 times 11 gig. So in other words, we need 44 gig. Only 44 video streams, not counting any audio intercom or maybe additional monitoring signals we provide. So, and as you see, 44 gig is not supported anymore with a 25 gig SFP, so we would need to go to minimum 100 gig QSFPs. Well, you could say, well, then just put a 100 gig QSFP in the camera, and then you are ready for all the different applications. Well, that would be a solution. On the other hand, this would also means even if you only want to use the camera in HD single speed, where you need only 1.3 gig per camera, you would need to use 100 gig QSFP in your COT switches, in all your network switches. So it would consume a lot of the bandwidth or block a lot of the capabilities in your system, and the cost of the whole installation would be quite high compared to the requirements. So this is not an ideal solution. Therefore, we looked into alternatives. So we believe that the interface needs to support the different bandwidth requirements in single speed, in high frame rate, and in high speed, and for the different video formats, HD, 3G, and UHD. And we need to have an interfacing which is adaptable. So there must be a way to have a field upgradability to different bandwidth requirements. So means SFPs which can be changed in the field between 10 gig, 25 gig, possibly even dual 25 gig and even 100 gig, offer very likely a future-proof and a very cost-efficient solution to that. And this is actually what has been developed. There is a small side cover on the camera, which can be removed. And as you see here, we have 3 SFP slots. The 2 lower ones are for 10 gig or 25 gig SFPs, and the upper one is for 100 gig QSFP. So why having two 25 gig SFPs? So actually there are so-called bidirectional SFPs available on the market where you can send an up and down link on over one fiber cable. And since we have in the SMPTE fiber cable 2 fiber cores inside, we can use one of the fiber cores for one bidirectional SFP and a second core for a second bidirectional SFP. So we can have a redundant IP output and input from the camera over the SMPTE fiber cable. To be fair, the cable itself is of course not redundant. If the cable completely breaks or somebody cut it in the middle, then your camera is lost. But this is not so likely. Much more likely is that you have maybe a bad connection, that you have dirt on one of your fiber connections. And then the second fiber normally still works perfectly fine. So you get a quite high redundancy by using two bidirectional 25 gig SFPs inside a camera head. And all applications up to single speed UHD is supported. Only in case you want to go to uncompressed 3x UHD operation, then you need to go to the 100 gig QSFP, which is the one in the top. And there's no redundancy for that one because of cost reasons and space limitations. We have not added a second redundant QSFP. But you have to see, no camera connection today has any redundancy whatever. So you have one cable, one connection. If that connection has any problem, your camera is lost. And with the bidirectional 25 gig QSFPs, you have a much higher redundancy compared to any camera you can use today. So once you have equipped the right SFPs inside the camera and you have connected the small fiber connectors to the SFP modules, then you have made your link to the camera connector on the rear side where you put your regular SMPTE fiber cable and you can run your 1 mile of, or even up to 2 miles of SMPTE fiber cable to your COT switch. So the only additional hardware you need on the camera side is a small power supply. So it's a very compact and efficient power supply. It also offers an option for redundant power input. So again, here you have then already redundancy on the power side too. Again, no camera system on the market today and even in the past ever offered redundant power input. This power supply, even so it's a ultra compact, it's only 2 rack unit height and 1/3 of 19 inch. This compact power supply offer redundant power input optional. So, and what the power unit does, it adds power to the SMPTE fiber cable, which runs for 1 mile or up to 2 miles from that small power box to the camera head. And in top of the SMPTE fiber cable, you see the 2 small fiber connectors here. In this case, is ST connectors, but you can equip the power adapter with different type of fiber connectors. And these 2 ST fiber connections goes then to your regular COT switch. It can be a Cisco, Arista, or whatever type of switch you want to use. And this offers a really robust and dependable link in the field, even more robust as what you have today. And to be format agnostic, there must be no active components between the SMPTE fiber connector and the 2 dark fiber connectors just above the SMPTE fiber. So actually, if you open that box, you see there is just a short fiber link going from one connector to the other. There is no active element in between. So it means this box is fully format agnostic for the IP signal. It supports 10 gig, 25 gig, 100 gig, or even any future standard as long as it's used single mode fiber cables. So this is a very future-proof and very robust solution for any application in the field. So native IP allows you to connect the camera over that small power supply to COTS hardware. And this COTS hardware deliver all the different IP signals from the camera into the IP network. And the camera can get any signal stream which is in the IP network to the viewfinder, for example, or as I said, with the gateway connectivity, functionality inside the camera head, you can also convert any IP stream into an SDI signal up to 12 gig directly on the camera. So the only thing you have on the receiving side is IP capable hardware. It can be a Cayenne switch, for example, from Cross Valley with the K-frame X with IP connectivity, or it can be any server which supports IP connectivity. So there is no dedicated camera hardware other than a camera control panel, which is required to control the camera. So no base station anymore, which need to be configured or whatever. It's just regular off-the-shelf hardware. And this connectivity supports any standard which the camera supports, which is today up to triple speed UHD. So that's up to 44 gig of bandwidth today. It's fully supported uncompressed. So means, in summary, you have the minimum deployment on the venue side because you only need a camera together with a small power supply and a COD switch. There is no latency other than the network latency. And this is the only solution on the world offer the full functionality and the full format support without any dedicated camera base station. One thing to remember is that it requires between 1.1 gig for that's for single speed HD in 50 frames, or 1.3 gig for 60 frames, but it can go up to 44 gig for UHD triple speed with a live output. So, but the question is, what is if this bandwidth is not available? In many remote applications, that might be not available. So we are working on a so-called JPEG XS option. This will be a software option. It's not a new hardware. It's just a software key you can purchase on a daily basis or perpetual, where you can apply a compression to your output streams. And also it can accept compressed signals on the input streams too in the same way. And JPEG XS offers an 8:1 up to 20:1 compression ratio. And typically it's claimed up to 10:1 compression, it's virtual lossless. So you can get basically an uncompromised optical performance with only 10% of the bandwidth. So if we were saying before it's 1.3 gig for single speed HD uncompressed, it will be a little more than 100 megabit per camera in HD with JPEG XS 10:1 compression. The nice thing is JPEG XS compared to regular J2K is that there's hardly any latency, because it's just a few lines of latency rather than a complete frame as with JPEG 2000. So it gives you an almost uncompromised workflow with only 10% of the bandwidth requirements. I have to say, this is not available yet. So this is a future development. So we expect to have this available sometimes early next year. So uncompressed direct IP, our native IP, is already available since this summer, and the compression option will become available early next year. But as said, there is no hardware change required in the camera. It's just a software license. So just an overview of the different options you have. You have the direct IP options where you connect the different Cross Valley cameras with the LEX8X series, so the 82, the 86, 86N or 85N cameras, as well as the new LEX100, connect over IP networks to the camera base station. So advantage is that if you have the base station on the receiving side, you have, of course, the baseband connectivity, you have all the IP connectivity in both standards, as well as in SMPTE 2022-6, as well as 2110. And you can still migrate from baseband to IP at any time you like, and you can already benefit from your flexibility of IP networks by doing remote productions or sharing resources between different studios and different venues very flexibly over the direct IP connection. But in addition, with the LDX 100, you have the possibility to use native IP. And with native IP, you also don't need any hardware anymore on the receiving side. You can just connect your camera to the IP network, and all is then managed by the camera itself. So, and here I want to show you a little bit of a practical, let's say, use case. So in example, you have a TV studio or a production campus somewhere, we call it here the at-home base, where you have your cameras connected over native IP into your IP infrastructure, and everything inside the infrastructure is IP-based, and you can do the control of any camera wherever it is in the building or on the campus just over IP. So here you have the extra benefit that you can share resources much more flexible compared to a typical one-to-one connection from cameras to base stations, and the base stations are connected into the infrastructure in the central equipment room or somewhere at maybe even different places in your building. But once you have such an installation, it is pretty easy to connect different venues like external sport arenas, like here venue A, venue B, with native IP, possibly because of the bandwidth requirements, native IP in this case with JPEG XS compression to the same IP network, and all the signals will end up at your at-home base in the same way as from the cameras which are on the same campus. So it really doesn't matter where they are physically located. All the signals end up in the same IP network. But you can also connect regional studios, for example, to the same network. So you have your main studio building and you have your regional studios all connected over IP together. And we have also use cases of that one already existing in the world. And you can extend that almost without any limits. So here in this example, you would do all the camera control or the shading of the cameras from your at-home base. So you could perfectly do that one. On the other hand, you could also do the camera shading directly on the venue or in the regional studio if you want. Or both shading places works also simultaneously together if that's wanted. But it goes even a step further, because once your signals are in the IP network, you can do the camera shading at any place in the world which have access to that network. So it means you can do really remote shading from a different location. So it means people theoretically can do shading from their home office. If they have a large bandwidth connection to your IP network, they can do shading from wherever they are. So this is an extreme flexible possibility, and you can migrate from an on-campus installation to a distributed installation using remote connections to your at-home base in any size you want. But in addition, the LDX 100 not only supports native IP, it also is backward compatible to the camera base station. So you can start using a camera base station if you still need baseband connections, for example, or if you want to use direct IP or whatever you want, but you can migrate to native IP at any time you want to. And you can mix and match cameras even in one production between native IP and direct IP and connection directly to an XCU and using the IP output from the XCU or the baseband output from the XCU. So you have all the flexibility with the system. So, but now I talk a little bit about a few features we have added to the complete camera system, supporting this, let's say, IP connectivity and the remote applications over IP. So here you see an image from our creative grading solutions, as we have introduced it approximately 1.5 years ago. And also the creative grading solution has already a lot of things built into the system which supports native IP or any kind of a remote IP application. But first of all, let's start with the camera. So the LDX100 has a built-in GPS receiver built into the hand grip of the camera. And based on that information from the GPS receiver, the camera can tell its physical location to the IP network. So it means rather than looking for a certain IP address when you look to a camera, you can look to a certain location. If you know you have cameras in the Dodgers Stadium in LA, then you can really look to the GPS information from the cameras which are around the stadium in LA, and then you know exactly where the cameras are located. So this is especially important for remote productions where you normally don't know where physically the camera is. You only see that a video stream from a camera with a certain IP address shows up in your network, but you don't know from where it's coming from. But with this GPS information, you know where the camera is located. Another new feature in the LDX100 is a built-in NFC connectivity. Near-field communication is supported, as you know, with most of the today's smartphones, for example. And we have an NFC app for Android devices as well as for Apple devices, which allows you to communicate between your smartphone and the camera head. And that is also possible even when the camera is not powered up. So you can take a camera out of the box without any connections to it, and you just hold your NFC device close to the camera, and then you can, for example, load new options, such as native IP option or high-speed options, or any kind of options you want to manage, you can load, or you can read status information. If you are not sure if the camera is already equipped with a high-speed option, just put your NFC device to it and you can automatically read the information from the camera, even so it's not powered. You can check even the IP settings of the camera. You can read usage information, like when the camera was switched off last time, when it was switched on, and so on. You can do much better logistic management as you do it today with the NFC device. And that's especially important if the cameras are used somewhere far out from the building, somewhere in the field, where there is no OB truck nearby and no maybe even a camera expert or an IT expert. You have just the camera operators together with the camera somewhere in the stadium. So things like this are very important. Another key feature is the easy diagnostics. As said, the camera might be far away from your infrastructure where you have your regular operational stuff. And if an operator connects a camera somewhere in the field and there is something not working well, it is very important that he can quickly find what's wrong. So we have a row of 6 LEDs. They are just somewhere behind the SMPTE fiber connector. And if they all are green, then everything is fine. Communication is working, the camera is locked, the streams is going out, streams is coming in, and all that is perfectly fine and working. If everything is up and running, the LEDs gets dimmed until you push the information button. So at any time you can push the info button and then you can read the diagnostics. So to make sure if all still is working, or if not, what's possibly wrong. At the same time, when you push the info button, you get a more detailed information in written text inside the camera viewfinder. So if not all the LEDs are green and one of the LEDs, for example, lock would not be green, but would be orange or red, you can look in the text in the viewfinder what the problem might be. So you get a more detailed text information about the diagnostics. So this is a very important part of the whole, let's say, IP solution. as said, approximately 1.5 years ago, we introduced the new creative grading solution, which is a new powerful camera control solution based on a new hardware control panel. We call it the creative grading panel here on the right, and an app which has been developed for off-the-shelf hardware. So in this case here, it's an iPad. So it's a standard app you can download from the App Store, loaded on off-the-shelf hardware, and then you can get an additional information and status information, and you can also fully control the camera from the tablet. So this is a very fast solution, which is very much self-explaining by translating settings into graphical displays, such as the example here on that screenshot here. You can see, for example, the light pass, where you see from the lens to the output where you are losing sensitivity inside your camera. And you can easily also change settings to gain more sensitivity if required. And this is also educative, because for every single function you have inside the system, which are, I think, around 300 different control functions, for every single one you have an info text. So it's a text block which describes what this function does. So it's, if you have a certain function which you don't know exactly what it does, like flare or knee point or slope or anything which you are not exactly sure what it is, just push the info button and you get a clear descriptive text telling you what the function is for and what it does. And it allows you to be extremely creative in entering into menus, which was hidden before and which was hardly used with the old control solution. So first of all, this is not related to IP, but in example, the GPS receiver information delivered from the GPS receiver built in the hand grip can also be shown on the Creative Grading app. So there is a screen which, if you select it, then you get a Google Maps view from the camera location, and you can zoom in, of course, and you can really see physically where the camera is located. So this is a small screenshot, for example, from our camera factory in Breda in the Netherlands, and that's a camera just outside the building. It's showing its position in the Google Maps app. And of course, you also get the GPS coordinates. So you can always look in a map, or if you know the coordinates of a certain place, you can always find out also by the coordinates. To be precise, to get the Google Maps view, you need to be connected to the internet. Otherwise, of course, you cannot translate the GPS information into the map view. But the map, the coordinates you also get without an internet connection. So in summary, so there is an ongoing evolution in the way how cameras are connected. So multi-core cables have been replaced by triacs have been replaced by hybrid fiber. The signals which are transmitted over the cable also have changed over the time. Analog video has been replaced by digital video, and in some of the latest cameras, digital video has been replaced by IP already. In the camera system with native IP integration into IP infrastructures offers a future-proof solution, because it uses off-the-shelf IT hardware with all the benefits of the IT developments. It's fully format agnostic. Today we talk about UHD triple speed. Maybe in 2 years from now we talk about 8K high frame rate, or maybe even high speed, or maybe 6 times speed in UHD. So it's an IP connection is always format agnostic, and it offers more operational flexibility by using IP infrastructures to connect your cameras to the IP infrastructure and then use the signals anywhere around the world, actually. So this was my presentation. I have to say thanks for listening, and I think it's now time for questions. Bob, I think you have been looking for the question. Have some question already been asked?
So thank you. That was awesome. There were SMPTE people texting me literally during it saying this is awesome presentation. So I had my first question you already answered, which was I was going to ask you about NMOS about IS 4 and 5, and then 7 for tally and that kind of stuff. We already answered that. One thing I was going to ask you is when you talked about the redundancy about using the SMPTE fiber and saying, okay, well, I'm going to do bidirectional, so I'll use redundancy there. Are you using -7 in that for the switching between the two?
Yes.
Okay, all right,
Yeah.
so that's cool.
So means actually what you need to do is you need to have two bidirectional SFPs inside the camera head, and then you use, they go to one SMPTE fiber, but use a separate core. And as I said, if the cable is completely cut, it's cut, so it's gone. But if typically, much more often, you have on one of the fiber pins maybe a little dirt or dust, and you have a bad reflection. So one of the cores is interfered. Normally, one is an up and down link. If one is interfered, you lose your camera. But in this case, still, since it's bidirectional over one core, so it's perfectly going out. And then you use on the small power box where you have the two ST connectors or SC or whatever you have equipped, you have one fiber goes into the blue switch and one in the red switch. And then you again need, this is a consequence, you need a bidirectional SFP in the switches, and then you have the full communication, and this is a full -7 redundancy. Yes.
Perfect. Okay. Great. I have a question here from the famous Craig Kuttner. In some applications, you described that multiple frame rates could be outputted. Can some of those simultaneous outputs be different HDR exposures for grading at home base?
Yes. So today we support, let's say, other way around. So you can choose if the camera operates in HDR or in SDR. And in most of cases, people would prefer to have the UHD or the 3G HDR and have an HD SDR at the same time. And this is fully supported. First of all, I should maybe mention in the LEX 100, for the first time, we support all the different standards. We support native PQ operation, we support native HLG, and also now native S-Log3. So you can choose between all the different standards which are used currently in the industry. And we have built inside the camera head, we have a down mapper from HDR to SDR, which can be set in different characteristics. So let's assume you want to have an UHD HLG operation. So this is your main layer. This is the main output, and then you have the monitoring output, and then you can choose if this is 1080i, 1080p, if this is SDR, HDR. So you can choose. Normally, that would be then maybe a 1080i SDR and then a UHD HLG at the same time, and that are two streams, two 2110-20 streams inside your IP network. And then you can register to the network, to the stream A or the stream B, and then you get UHD HDR or you get 1080i SDR, wherever you want in the IP network.
Does that also apply to 709 or 2020?
Yes. You can choose inside the camera. We support 709, we support 2020, and we support LMS. So the ICTCP operation is also supported by the camera. We do that with all our UHD cameras already for a couple of years. So we actually is when the Dolby applied for the SMPTE standard for the ICTCP, we worked already with Dolby on that one. And at the moment the standard was published, we switched the function on basically at the same time.
Nice, great. Well, that's great. That's all the questions I have right now. Thank you. That was a lot of information, and I love the part about the way you explained the uncompressed and then going to JPEG XS and all that, and the fiber, and as far as the SFPs and the difference in the bandwidth and all that. That was really good. Thank you for going into that. Very good.
Yeah, as I promised, I will provide you with a PDF of the slide deck. And in any case, if anybody of the audience would have any questions about our cameras, technology, or whatever, feel free to contact me at any time. The email address is quite simple. It's my first name dot family name, so klaus.weber@crossvalley.com. So feel free to contact me, or you can connect to me over LinkedIn if you want. I'm happy to support you whenever I can.
Excellent. Thank you. And thanks for staying up late.
No problem. Thank you for giving me the opportunity to present our technology. It was a pleasure. Thank you.
All right. Well, thanks to you and Trip. We appreciate it. And hopefully next year, if you come to Atlanta, we'll have you to a meeting and we can have some barbecue again.
Yeah, that would be great. Okay.
Well, thanks everybody for joining. I really appreciate it. That was great. We'll post an update about the date for next month. So thank you so much, Klaus. Have a great day, everybody.
Okay. Thank you also.
Bye-bye.